Hello and welcome everyone. In this video we will be covering Python programming. It is one of the most popular programming languages, and if you um, type top or most popular language in 2024, Python will be one of the top few, or if not the top one. It is an interpreted high-level general purpose programming language, and it is used in many applications. For example, if you want to build a web app, you can use Python. If you want to do some scientific programming, you can still use Python because it's a lot easier to use than C++, and it saves a lot of time, and you can build your prototype very quickly using Python programming. And also, if you are interested in machine learning, Python is the most popular choice. So this video, we will try to cover as many topics as possible about Python programming. The topics that we will cover are basically data types and structures. So we'll be covering these few: strings, lists, and tuples, dictionaries, and sets. These are the few that we use quite often. Then the conditions, if else, and different types of loops. And then we will see what lists and dictionary comprehensions are. We can we will also see what functions are and how they are used to reduce redundancy in the code, and we write functions so that we could use it in different programs, and we don't have to repeat ourselves in every code file that we write. Um, we will also see what decorators are, and finally, for object-oriented programming, we'll be looking at how to write different classes. Um, so let's start with data types and structures and see what they are. But before that, please don't forget to subscribe to my channel for more videos like this. On my channel, I have videos on math, programming, and machine learning topics. So please check those as well, and please like and share. So what are data types and structures? These are simply variables that we use to reserve some space in memory. So for example, we have two variables a and b, and we assign them a value of 1, that is an integer, and to b we assign a string, which is John. So we can see their memory addresses where they are stored on the memory using this hex ID, and this gives us their memory addresses. So we can also write another these different items in a container called lists. So let's say we have apples, and then we have an integer, then we have a float, and we want to check the memory address of this container, and we can see the address in this case. So here in the container, so each of the elements have their own memory address. So if we want to check the memory addresses of those elements, we can also print those using hex item and print, and that gives us three different addresses which are different from the address in the container. Now let's look at the first data structure in our topic list, and that is strings. So what is a string? A string is a contiguous set of characters represented in quotation marks. We can write a is equal to John. So these quotation marks can be single quotation mark or a double quotation mark. Doesn't matter, but we can't use the starting quotation as double and the other one which is different from the starting. So both the starting and ending quotation mark should be consistent. Okay, so we have a is equal to John, and then for example, we said it's a contiguous set of characters represented in quotation marks. So we can see at what index what letter resides. So if the indices start from 0, so we can see 0 and maybe let's see 1. So it should give us the letter O, and that's what we get. So we can also slice a string. So we can, if we want to slice the element 1, 2, 3, so we only want to keep the middle two letters, so we could also slice it like that. And we can, if we want to slice the first two, so we can see the first two, we can also look at the last two, and yeah, so if we want to flip the letters, so we could also flip it. Okay, so this was the string slicing. We can also use many other functionalities using strings, and these are very, very important in natural language processing as well. So if we know how to use this kind of functionality, for example, we have a long string, or we have a full name, for example. Um, so we say, okay, so um, John Smith. Okay, so that's the full name. And if we want to get the first name and the last name out of it, so we could quickly use the methodology. So we could get the first name and last name, and we could use full name split, and split will be on space, and we can print the first name comma last name, and we can see we got John and Smith. So um, so it's very powerful in that. Another way, if we want to now combine these first name and last name in a different format. For example, we want to first display last name and then comma and then the first name. We could also do that using the join, and we could say um, first name, last name. And if we do see that it's John Smith, so we could put a space here. Sorry, it should be last name first and first name, and now we have Smith John. That was how we could use the split and join on strings and quickly change or update the string or extract some information um, from a longer string. We can also find letters as well in a string. So for example, if we want to find full name dot find, and we want to find letter M, where it is, and we can see it's on index 6. So that gives us the index when letter first appears. So we can also see the index when it last appeared. So for example, yeah, so here we can use rfind to see when this letter last appeared. So in this case, it has only appeared once, so we don't see any difference. But let's quickly see another string. So we can see car make, and we say it's a Ferrari, and we try car make, find letter R. So that should give us the index 0, 1, 2 and 2, and then the R find should give us the index 0, 1, 2, 3, 4, 5. So 2 and 5. So that's the answer, and that's what we got. Okay, so now if we, for example, have a string question, how was your rugby game? Okay, so now we want to see, okay, how was your rugby game? We could quickly change it, rugby, to maybe some other tennis. So we could do that. Quick question dot replace, and we want to replace rugby with tennis. And how was your tennis game now? So yeah, it's pretty handy, and we could also see how many times letter appeared in the string. So if we say question dot count, in this case I want to see how many times y appeared in this string. So it appeared twice, and this is because this did not save it. So if we want to save it, we'll have to say question is equal to question dot replace. If we want to check which question do we have, we still have question was your rugby, how was your rugby game. And yeah, let's see if we can see there is an option in place, true. Okay, so no in place. Okay, so we can write question, and this time counts of y are 1 and question has been changed. Okay, so one other application which is also very useful in string processing is changing the case of the letters. For example, sometimes we want to make letters or words appear in uppercase letters. Sometimes we want to make them appear in lowercase letters. Sometimes we want to capitalize where only the first letter in this string will be uppercase. And sometimes we want to use the title uh, case letter. So first letter of each word in the string will become uppercase. Well, we can um, see how does that work. For example, we have a string which is um, let's say Python is an amazing programming language. So now we have everything. All these words are starting with an uppercase letter except amazing and is an N. So if we want to, let's say, capitalize, so A, oh, I need to run this one, A, and Python is an amazing programming language. So now P and L. So only the first letter in the string becomes capital or uppercase, otherwise, whereas the remaining letters are all lowercase. So if we want to change it to title case, so let's see how does that look. In every word, first letter has become uppercase. So very powerful functionality over here as well. So sometimes we want to format our document. So let's see, we have a formatted string, and this time we have a report like, and we want to separate sections, but we don't want to uh, uh, write just the string here like section 1. We want to make it look pretty, so that and more highlighted in the document, so we could use dashes, align it in the middle, and um, we can uh, yeah, show it like this. So now it will be clear that the section 1 has started, and we could continue with the content for the section 1 after that. So that's very powerful. Similarly, if we want to align it towards the right, and then we start section 1 like that, or we can also align it like this, so that is section 1 to the right. So this is also very powerful. Similarly, in the uh, uh, case of let's say we are dealing with currency or um, uh, some amount, so we could use, instead of writing these zeros where we don't know like or how to count these zeros, it becomes very difficult. So we could use the same string formatting and put amount, and then we could add comma separation, and if we run it like that, we get uh, the amount as a string, but in a nicely formatted way. So that was pretty much it about the strings that I wanted to share in this video. So let's look at the next topic, which is lists and tuples. So what are lists and tuples? So these are ordered sequences of objects. The only differences between these two are lists are mutable, whereas tuples are immutable data structures. It means that once we assign objects to a tuple, we cannot change this under any circumstances. Um, so we already saw a previous example of a list where we created a list in the cell 3. We saw we had included apples, which is a string. Then we included an integer and a float. So list and tuples, in those we can store any data type. So there is no requirement that we should always store the same data type in lists and tuples. So yeah, let's start with seeing the functionality for lists and tuples. So we'll start with a simple list. We call it A, and here maybe let's say we have a list of fruits. So we have apples, oranges, and grapes, and strawberries. Okay, so that's our list. It has 4 elements. We can use the same slicing, array slicing that we saw in string to see different elements. For example, we can see the first two elements, we can see the last two elements, we can also see the middle two, so 1 2 3, and that's gives us the required elements. So we could use the slicing feature to extract the elements that we want from the list container. We can also, as I said, like lists are mutable, so we can change the elements as well. So for example, our list has changed. Now instead of oranges, we want um, to see, let's say, pineapple. So pineapple. um, so and then we see what changes did we make to the list. So now the second element in the list has become pineapple instead of oranges. Okay, so and tuples is the okay, so let's first see the functionality with lists, and then I'll talk about tuples. There are different ways we can create a list. So an empty list can be created, for example, using the list constructor. So we can see that A is a list, so that's an empty list. B is an pair of square brackets and without any elements in it. So both are giving empty lists. So oh sorry, um, so both are empty. Um, and as I said, like list can contain data of different types, so there is no requirement that all of these data types should be string. We can also store different data types into it. So now let's say we want to add an item to a list. Okay, so we have the same list, for example A. Okay, let's use A and B. And what do we want? We want to store add, let's say, apples to our list. So we can use a dot append and we can add apples. Okay, so that's the first item we wanted to store, and now we have apples in our list. Okay, so now we also want to add for example grapes and strawberries. Okay, so how are we going to add both of them? So grapes and strawberries are two items in a container, so we can extend our list so and give grapes and strawberries. So what extend will do, will um, see, now we have our list extended to apples, grapes, and strawberries. Okay, so now we also want to add pineapple to our list, but we want to add it at index 1. So how are we going to do that? So we can do a insert, and we can provide the index, and we can add pineapple to it. And if we print our list again, so now we have the same list: apple, pineapple, grapes, and strawberries. But now we saw different functionality: append, extend, and insert. So with these functionalities, we can quickly manipulate our list, add more items to it, and expand our list too. So now what about removing items from the list? So how are we going to remove item from the list? So for example, if we want to remove an item that is the last item in the list, we could use the pop method, a.pop, and we can see what A is, and now it has removed strawberries from our list. Similarly, if we want to remove an item from a certain index, we can also remove that. So for example, if we want to remove a pineapple from our list, we can give index 1, and that will remove the fruit pineapple from our fruit list. We can also use remove and give the fruit that we want to remove. We want to remove apple, and print. So our list now has only grapes in it. And yeah, we can also use, for example, let's add a few more again. Um, um, apples and bananas. Okay, and now if we want to remove grapes and apples, so let's first see. Um, so we have grapes and apples and bananas. So now if we want to delete the first two, so we could also do that using the del and now we are only left with bananas. So these are very powerful methods that we could use and make our coding um, much easier and simpler. Um, so for example, if we want to now clear our array, we can use a dot clear, and that should clear all elements in the list, and we should have an empty array in the end. Okay, so this was all about how to add and remove elements in the list, slicing lists, and what about sorting lists? So for example, we have a list which is which contains different numbers randomly placed. So we have 8 here, but then we have 0 and then 7 and -3 or 2, -2, and yeah, so that's what we have. So we could use the uh, sort method, so that should give us the uh, ascending sort. So we have a smaller number, and then we are moving on to the bigger and bigger numbers, or we could use the sort, and we could say reverse equals true, and that will give us the descending sort. So now we have a bigger number, and we're going to smaller and smaller numbers. We can also flip the list. So we have done so in the string slicing one as well, but here we could use the reverse method for the list, and we can print A again. So now the list has been flipped. We can also do the flip using the slicing notation convention, and so if we do this and print again, so we get the same values here. We also want to see some operations on the list. For example, we have two lists, so L1 and L2, and we have 1, 3, 5, and 2 and 6. So if we want to concatenate them, so how are we going to do that? Is concatenation of list is very simple. So L1 plus L2, and that uh, should give us 1, 3, 5, 2, 6, and we can also get the same value using L1 dot extend with L2, and that should also result like this. So in this case, L1 has been extended to L2. Yeah, so now we can see we get the same results using L1 here. Now we have seen about lists. Let's talk about tuples for a bit, and it's very similar. So we can use T1, T2 and use the tuple constructor to create an empty tuple, and we can also use parentheses to create tuples, and both are empty tuples. So now if we want to append, let's say, so there is no append because tuples are immutable, so we won't be able to append anything here. So for example, we create our fruit list again, but as a tuple. Okay, so now if we want to change our fruit list, let's say we decide we don't want grapes, instead we want oranges, can we change it? No, we won't be able to change it again. So tuple object does not support item assignment. So if we want to create make this change, we'll need to create another tuple with apples and oranges in it. So because these are immutable. Okay, so one other important application of lists and tuples is that of unpacking a sequence. So now lists and tuples are both ordered sequences of objects. So if we want to really see or, the elements as a variable, so we could also do so because we have fruit list. So let's see if we still can see fruit list. So yeah, we have two elements, so we can unpack these using A and B. So A and B should be our fruit list again, or I should simply say A is apple and B is grapes. Uh, Okay, so similarly, let's say I have a tuple of or list of um, let's say this time I have baseball list of sorry, yeah, not food list, let's do sports list this time. So we have baseball, soccer, and basketball. Okay, and we have football, and let's put ice hockey as well. Okay, yeah. So we have our sports list here. Now if we want to um, uh, unpack this sequence, so how are we going to do that? So if we want to get only baseball and not the rest, so we could simply say A is equal to sports list, and that should only give us the value of baseball. Um, if we want to get A, B, and nothing else, and then ice hockey, we could also do that and see, let's say sports list, and our A, B, and C would be baseball, soccer, and ice hockey. So that's a really cool trick we could use to um, unpack the sequences, and sometimes these are very useful when we are working with functions and we only want to use some of the outputs of the function into our programs. Um, so that was all about lists and tuples. Now let's look at the dictionaries. So dictionaries is another data structure, very popular one. So it's a collection of key value pairs, but with the requirements that keys are unique. So we can't duplicate the keys, but the values can be duplicated among different keys. So let's see how we can create dictionaries now. So we could use the constructor, so d1, d2, and we use the um, curly braces to create dictionaries. And if we want to see the types, so we can use type and d1, d2, and these are both dictionaries. Now non-empty dictionaries, as I said, like they have key value pairs. So for example, we have d1 equal to let's say um, the grade score, maybe like here for different students. So let's say John got uh, A plus, whereas Michael got an A, and Smith got um, a B plus. So these are key values, value pairs. Um, so we have keys and we have some values assigned to them. Um, yeah, let's say Sean instead of Smith. Okay, so got B plus. All right, so D1, and now if we want to see what are the keys, so we could see D1 dot keys, and we can see keys are John, Michael, and Sean, and what are the values? We could also see that A plus A and B, and we can also see the items in this as a pair. So John A plus, so these are tuples, so Michael A and Sean B plus. So now we can also create dictionaries using keys and um, values. So if we have two keys, for example, we have names, let's say the same way, keep the same John, and let me copy the rest of it from here, John, Michael, and Sean, and their grades. So we have two lists, and let me copy this from here. So what do we see? We see two lists, two containers, one containing names and one containing grades. Now if we want to produce our D1, again we can see use the constructor dict, and then we use the zip method, and we can zip names and grades together and apply dict. So D1 should be the same dictionary that we built earlier. So John A plus, Michael A, and Sean B plus. So again, very powerful technique here, creating dictionaries and uh, checking their keys and values. We can also see how to access value corresponding to a specific key. There are different ways of doing that. We could either say D1 and we can specify the key here, or we could simply say D1 dot get and then John. So both have their own uh, um, so both will give us the same results, which is a plus a plus. The only thing is that, like, let's say we try this here. If we see this here, um, so let's say if we call for a key that is not in here, so this notation, the left one, will give us an error, whereas this one will still work because this will use a default value of none and return that. So let's try that. So we see James this time, and um, here we got an error, but if we try d1 dot get James, we don't get an error because it's returning a none value. Okay, so that was dictionaries, how and to add and remove or update, that we also want to see. Now that James is not in that dictionary, we can add James to that dictionary. So we could say James, and we can assign his grade. So maybe he has also not performed well, so in the grade, so James is getting a B. So John A, Michael, and Sean B, and James B. So now we have another, let's say, two students with different grades. So we could also do that update here. That let's say we have um, uh, Steve. So let's bring in Steve and see. Maybe he's an A student, and then yeah. So Paul. So Paul is an A plus 2. So um, let's update the dictionary with these two, and we can use the update. And now we also get John A, Michael B, Sean, James, Steve, and Paul all in our dictionary. Now how can we remove a key from our dictionary? We could remove our dictionary. Let's say Paul didn't get uh, or Paul was not part of this class, so we could remove Paul. So we could say d1 pop and then Paul from the dictionary, and you can check again. So now Paul is not part of this class, and his grade is not included in this dictionary anymore. Um, okay, so we can also remove using the del method. So we could use del and d1, and this time let's say James also was not part of this class, so we want to remove James from this class, so we could also use del and remove James from this dictionary. Okay, so if we want to remove all values, so let's say all of our grades are not correct and we want to repeat the exercise, we can say d1.clear and it should be empty dictionary again. So how are we going to see, for example, if a key is in a dictionary or not? So let's say we update our dictionary again. We bring in Steve and Paul again. So we realize that Paul was in this class. So we bring Paul again. D1 is Steve A and Paul A plus. And now we want to see if Paul is in this class. So Paul in D1, and we want to see that yes, we can check if any key is available in our dictionary or not. So using in dictionary or in key in dictionary command. Okay, so this was all about dictionaries that we wanted to see in this video. And now let's look at our last topic of this video, and the rest of the topics we will cover in the uh, subsequent parts, and will be soon uploaded on my channel after this. Um, so what are sets? So a set is an unordered collection of unique hashable objects as its items. So most of Python's immutable built-in objects, so such as integers, floats, or strings, those are hashable, whereas mutable containers such as lists or dictionaries are not hashable. But before we do this, one important thing that I just remembered is so let's say we have a list. So let's say we have a list A1, 2, and 5, and we cannot create another list and say b is equal to a, and because if we look at b, so and a, so both their memory addresses will be the same. So what this means is that if you change any element in b, so let's say we make this second element to 0, change the second element to 0, then we want to type a and b, we can see a is also changed. So the correct way of doing that, and that also goes to the dictionaries as well, so we, whenever we want to make a copy of it, we'll have to say a dot copy, so that will create a proper copy of a, and their IDs will be now different. And if we want to so now their memory addresses are different, and now if we want to change, let's say copy this code here and change it back to 2, we can see only b has changed, whereas nothing has happened to a in this case. So yeah, just remember this when you are writing big program, big computations. So this is a very common mistake that we can make, and the same array or the multiple arrays get updated, and that affects the results of our calculation. So very important to remember this. So yeah, coming back to sets again, set is an unordered collection, and that's a data set of unique hashable objects as its elements. Um, so a set itself is a mutable data structure, so we can easily add or remove items within a set. There is no notion of index positions because it's an unordered collection, and that's why we cannot slice it. So we don't know the order of uh, uh, any object. And we won't be able to use the slicing features here. So why are sets useful? These can be used to efficiently remove duplicate values from a list or tuples, as sets can only store unique elements. And we can also use these to perform common math operations like unions and intersections. So how are we going to create sets? So for that, we'll use the set constructor. So s1 is equal to set and s1, and so that's a set. We cannot use the curly braces as we saw before, that creates a dictionary. So we can create a set, for example s1 is equal to 1 3 5 4 and 4, again 2 and 3. So and if we print, so now you can see that even though we have written 3 twice in the set, we can still see only the unique elements in the set. So that's also very powerful feature, because we can easily remove duplicates in our list or container, or by just converting it to set. So for example, let's see, we have a set of integers, sorry, uh, vowels, so a, e, I, o, u, and we can see we have because the string acts as a contiguous set of characters, so these can be indexed and sliced, so we see each letter as a value in the set. So how are we going to add element to a set? For example, if we want to add element in s1, for example s1 is add and we want to add 7, then s1 will be 1 2 3 4 5 and 7. Similarly, we can use for example, we have another set, um, so we can use update method to um, let's say 8 and 2 again, and see. So we only added 8 because 2 was already available in the set s1 before, and now the current value is 1 2 3 4 5 7 and 8. Okay, so this was how to add any elements, how to remove an element. So we can do different methods. We can use different methods. For example, s1 dot remove, and we want to remove 5 and s1, and that has removed 5. And we can also use discard method, and again we specify 4 um, s1, and that has removed 4 from the set. We can also use the pop method. So it's here. So if we use pop and s1, so now we have removed the first value here from the set. Okay, so now we will look at the operations, union, intersection, and differences. So let's see how that works. So for example, we have S1 and then there is S2. S2 will be, let's say, 3, 7, and 10. Okay, um, so now we want to see, okay, the union operation. So S1 dot union of S2, what's that? That is 2, 3, 7, 8, 10. And if we want to do the same operation on, we can also do so like this. So 2, 3, 7, 8, 10. Similarly, we can also do the intersection, which we should give us the common element between these two. So the intersection S1 and S2 um, will result in 3 and 7. So these are the common elements, 3, 7, 3, 7. And we could also achieve the same using and notation, 3, 7. Then we could do the differences as well. So S1 difference S2, and that is giving us 2, 8, because we remove 3, 7, 8 from S1 and we are, or 3, 7, 10 from S1, and we are left with 2 and 8. And we can simply use S1 minus S2, and that should also give us the same value. So now if we want to check if an element is in the set, so for example we want to see 4 in S1 and 7 in S1. So one is false and one is true because 4 is not available, not present in S1, whereas S is a part of S1 set. Okay, so now we can also see if a set is a subset of another. So let's say we have S2, discard 10. So we have S2, 3 and 7. So now if you want to see S2 is a subset of S1. So set has no attribute is a subset. Okay, so is subset. Okay, yeah, so that is true now. So S2 is subset of S1. So this is true because 3, 7 is part of 3, 7 in that, so it's a subset of S1. Okay, so that was all about sets as well. I hope you like this video. This was a very long video. I normally make shorter videos, but this time it was longer. I hope it's worth it and you guys like it. And yeah, please leave a comment below in the comment section, and also please don't forget to subscribe to my channel for more videos like this. Thanks a lot, and thanks for watching.